That means the higher the percentage, that means it's responding to treatment. Okay, so they found that with that, more than 70% for this type of cancer. And for the more difficult cancer, what are the difficult cancer? The difficult cancer are like pancreatic cancer, breast cancer, and a very difficult one is the triple negative breast cancer. Okay, so they've done a lot of tests on a lot of cancer, and can see the two color here. The purple color is like the lung cancer, liver cancer, colon cancer, and gastric cancer. Yeah, they found that in the Trineo biotech lab, again very white using the GLP, that treating mice with the YKC can actually achieve a tumor growth inhibition rate of over 70%. What is tumor growth inhibition rate? It is a very commonly used term to quantify the response of treatment, whether of the drug or whatever you give to manage cancer, what is the response rate? That means the higher the percentage, that means it's responding to treatment. Okay, so they found that with that, more than 70% for this type of cancer. And for the more difficult cancer, what are the difficult cancer? The difficult cancer are like pancreatic cancer, breast cancer, and a very difficult one is the triple negative breast cancer. Triple negative breast cancer is that the cancer is actually triple negative, means it is actually, they test it, the three receptor, there's estrogen, progesterone, and the human epidermal growth factor receptor, HER2, is all negative. Okay, so it is not a very common cancer, but it is one of the hardest to treat cancer. So in the lab, they actually done the test and found that treating mice with this type of cancer, it can actually also achieve a tumor growth inhibition rate of more than 50%. Okay, there's also another type of cancer called multiple myeloma. Multiple myeloma is actually a cancer of plasma cells in the bone marrow. Okay, the impact of that is a very different kind of cancer where you cannot say whether it spread to the lung or to the liver. Okay, but you can see the damage or the severity of that cancer is on the damage it does to the whole bone structure, and it will affect, because bone marrow is the place where blood cells are formed. So if you have multiple myeloma, the blood, healthy blood cells production is really affected. Okay. So how did they test on the multiple myeloma, the impact of YKC on multiple myeloma cancer? Okay, as I mentioned, it actually affects the bones, right? So this test is done by taking the specimen from the lumbar spine L5 of the mice damaged by suffering from multiple myeloma. So you can see this is the slide of a healthy mouse, where you can see a differentiating color, pink, healthier formation, right? Now, this is the mice that has got multiple myeloma, no treatment, no YKC. On the right is the mice, the slide of the tissues or the cells of the mouse that is treated with YKC. You can see that the cellular structure and the color is quite close to the healthy mouse. Okay, and also when they correlate with they did a test, a scan to scan the mice itself. Okay, on the healthy mouse, you can see when it's scanned, it is all blue. There is no much contrast. So this scan test says that actually, if the fluorescent light is very bright and got orange and got yellow color, that means that the cancer cells are more significant. There are more cancer cells affecting the bones of the mice. So you can see when this scan is done, as expected, the mouse that is not treated with YKC, you can see the contrast here. There's got a lot of patch here versus the mice that is treated with YKC. There are no brightening of the fluorescent light. That means the cancer activity is not there. Okay.